That was a launch of one of the University of Queensland's high-shot flights. A two-stage rocket was used to launch the payload, and the payload was a scramjet combustor. The rockets pushed the payload up to a maximum height of around 300 kilometres. When it fell back to the Earth and reached an altitude of around 30 kilometres, the scramjet combustor was exposed to a flow at Mach 8, and some hydrogen was injected and burned in the combustor. Welcome to Hypersonics, from shockwaves to scramjets. I'm Professor David Mee from the Centre for Hypersonics in the School of Mechanical and Mining Engineering at the University of Queensland. I'll be one of your guides for this course. In this unit, we're going to look at the structure of the course and what's coming up. As the title of the course suggests, we're going to take a journey through the field of hypersonic flow. We'll start with some history and background, and then work our way along a path that will take us from the fundamentals of high-speed flows and through some of the interesting concepts and principles in the field. The ultimate goal, and the focus for everything we'll be doing, is to take you to the point where you can analyse the flow through the type of engine that's likely to power craft that will fly at hypersonic speeds into the future, the scramjet. If that sounds a little daunting at present, don't click the stop button just yet. We've structured the course so that there are two paths that you can take through it. I expect that some of you are interested to find out more about hypersonics and what these scramjet engines are all about. But perhaps you don't think you have the background to go into all the details. Well, we have a path for you through this course. For each of the main sections, we'll introduce some basic ideas that will point out the basic physical principles and ideas behind why we need to think about hypersonic flows differently from lower speed flows. We'll also provide an overview of the principles underlying how we can use the oxygen in the air through which a hypersonic vehicle is flying to burn fuel and produce thrust. So by the end of the course, you should have a good understanding of how scramjets work. And for those of you who are keen to go into the details and who have the background of some calculus and some basic fluid mechanics and thermodynamics, well, we should have just what you're looking for. We'll take you into the details in each section of the course after we go through the basic ideas. Then we'll give you the opportunity to apply the ideas to analyse the performance of your own scramjet engine in the project at the end of the course. Along the way, we'll have some questions for you to answer, and for those going into the details, some problems for you to work through. Some of these will be formative, for you to check on how you're progressing in your understanding of the course, but that don't count towards your final mark. For those wanting to get a certificate for completion of the course, there will also be some summative assessment in the form of a quiz at the end of each of the main sections of the course. Section 7 will introduce the project, which will also form part of the assessment. For those going through all the details and undertaking the assessment, you'll need to obtain an overall mark of at least 50% over all of the summative assessment items in the course in order to pass. Let's have a brief look into what's coming up in the course. In Section 1, we identify what we mean when we say that a vehicle is travelling at a hypersonic speed. We'll look at what sort of vehicles do travel at hypersonic speeds. We'll also identify what shockwaves are and what a scramjet is. It's the components of a basic scramjet configuration that are the focus for the next three sections of the course. Section 2 is all about isentropic flow, such as might occur in an expansion nozzle of a rocket or in the nozzle of a scramjet. In Section 3 of the course, we'll look at shockwaves, where they occur, and how we can determine the changes that occur in flow properties as a gas passes through a shockwave. In Section 4 of the course, we'll look at what happens to a compressible flow when you add heat and where there's friction at the walls containing a flow. These are the types of phenomena that occur in combustors in scramjets. In Section 5 of the course, we'll look in some more detail at some of the important things that happen when we reach hypersonic speeds. In Section 6 of the course, we'll concentrate on scramjets, their history, performance, and how they might be used in the future. Finally, in Section 7, we have the project, where you'll get a chance to apply what you've learned to look at the performance of scramjets. So I think you should find some interesting ideas in the course, and maybe this will be a motivation to take you further into the world of mechanical and aerospace engineering. But that's enough talking from me. Let's get this course started.